Today I am going to start chapter number 3, and this chapter number 3 is metals and non-metals. Metals and non-metals. Children, there are 118 elements present in periodic table, and we can divide all 118 elements present in periodic table into 3 categories, that is metals, non-metals and metalloids. In this chapter we are going to study the physical properties of metals and non-metals as well as the chemical properties of metals and non-metals also. Most of the property we will study of metals only, and few properties we will study of non-metals. Now, properties of metals and non-metals. First, we are talking here about the physical properties. Physical properties. First physical property, and that is lustrous. Lustrous. Lustrous terms means that the metal are having shiny surface. You must have observed metal like gold, silver, copper. If you are taking these metal or you are seeing these metals in a pure form, so they have the lustrous surface, the shiny surface. The property of metal of having the shiny surface is called metallic luster. And children, we have already learned the metals lose their shine when we are exposing these metal in air for long time, and this is called corrosion. Next property is malleability. For example, if we are taking one metal like iron or aluminium and we start beating that iron metal or aluminium metal with hammer, so we will find that the piece of iron or piece of aluminium start turning up into a thin sheet without breaking. This property is called malleability. The property which allows the metal to be hammered into thin sheet is called malleability. Now, third physical property, ductility, or metals are ductile. Again, metal like copper, magnesium, iron, they are very much available in a form of wires. The property which allows the metals to be drawn into thin wires is called ductility. It is also one of the characteristic property of metals. Gold is the most ductile metal. Copper, aluminium, they are also very ductile, and you all know we used to use copper wires for electricity purposes. Next, good conductor of heat and electricity. Good conductor of heat and electricity. Metal allows heat to pass through them easily. For example, if you are taking one aluminium rod or iron rod and you start heating one of the end of the rod, so what will happen? The another end of that rod will also becomes warm because the metals are good conductors of heat. Again, metals are good conductor of electricity. Metals are good conductor of electricity, or metals allow electricity to pass through them easily. And the electricity will pass from one corner to another corner of metal due to the free electrons present in it. Next property, generally children, metals are hard. Metals are hard, that means metals are very much strong enough. They can hold large weight without breaking, or you would say without snapping. For example, iron metal is really very strong, and due to this property of iron, there are metal. This iron metal is used in the construction of bridges, buildings, and all. Though most of the metals are hard enough, but sodium and potassium metals are not that strong. Next property, sonorous. Metals are sonorous, means if you hit metal by something, they will produce a striking sound, and this property is called as sonorous or sonority. It is due to the property of sonorous that metals are used to making bells and strings of musical instruments like sitar or violin. Children, I just now told you metals are really hard. That is why generally they used to exist in a solid state. And I can say except mercury, which you already know, mercury is liquid. Generally all metals are solid. Next property, metals have high melting or boiling point except gallium and cesium. Children, gallium and cesium, this is this year's question. In 2020 it was asked, give two examples which have low melting point of metals. The example is gallium and cesium. These are the metals. If you keep these metals on your palm, they will melt. That means approximately the melting point of these metals is equal to, you would say, or less than our body temperature. Metals, next property is they have high densities. Except some metals like lithium, sodium, potassium, all metals have high densities. And the soft metals like lithium, sodium, potassium, these metals are soft metals and they can be cut with knife because they have low densities and low melting points. And the last property, last physical property of metal is metals give rise to basic oxide. Now, non-metals. Children, non-metals are very few in comparison with metals. That means you can say the number of non-metals is less than the number of metals. Few examples of non-metals: carbon, sulfur, iodine, oxygen, hydrogen. You must have heard it. Generally, non-metals exist in like all three kind of states. They can be solids, they can be liquid, they can be gaseous also. And children, one important thing is on the basis of their physical state, we cannot fix the chemical property or the physical property of any element. And third property, for example, non-metal like iodine is very much non-metal and it is lustrous. Lustrous is the property of metals, but iodine is lustrous. Non-metal can exist in different forms. And the most important property, most non-metals produce acidic oxide. Students, just now I gave you examples: carbon, sulfur, iodine, oxygen. If I take oxide of carbon, carbon dioxide. If I take oxide of sulfur, sulfur dioxide. And for example, if I am dissolving carbon dioxide into water, it will give me acidic solution. If I am dissolving sulfur oxide in water, it will give me acidic solution. So we can say basic oxides are of metals oxide. Acidic oxides are of non-metal oxides. Alright. Now chemical properties. Chemical properties of metals, and first property is reaction of metal with air. Actually, we are doing reaction of metal with the oxygen present in air. When metal is burnt in air or metal is heated in the presence of air, metal will turn up into metal oxide, and the nature of this metal oxide is basic. Means when we are dissolving this metal oxide in water, we will get basic solution. Now children, the vigor of reaction, or you would say the speed of reaction, will depend upon the reactivity of metal. Children, in last chapter we have learned the two metals, sodium and potassium. These two metals are very high reactive metal, or the reactivity of these two metals are quite high. Sodium is less reactive than potassium, but having very good reactivity. Children, when sodium and potassium two metals are taken individually and we are burning these two metals at the room temperature, they will turn up to their oxide. We have taken solid sodium, we are burning in the presence of air, it will turn up into sodium oxide, which is solid. We are taking potassium, we are burning this potassium in air, it will turning up into potassium oxide, which is solid. Now, when we will take this sodium oxide or potassium oxide and dissolve in water, so they will turn up into their hydroxide. Sodium oxide react with water to give sodium hydroxide. Potassium oxide react with water to give potassium hydroxide. Children, the solution which is formed after dissolving these oxides in water, it is basic in nature. And after seeing this reaction, you must be understanding why they are basic in nature. Sodium hydroxide is a base because when we are dissolving in water, it will give us hydroxide ions, and these hydroxide ions are responsible for the basic character of this solution. Next, magnesium. Magnesium also react with metal, but we need to provide little heat before the reaction. Magnesium metal first will be heated, then it will start burning, or the reaction will start when magnesium will get little warm. Magnesium similarly react with oxygen to give you solid magnesium oxide, and when this magnesium oxide is dissolved in water, it will give you magnesium hydroxide. Again, this magnesium hydroxide solution is the basic solution. Next, aluminium metal. Aluminium metal, again, because aluminium is less reactive than magnesium, so we have to provide heat to aluminium metal also. And aluminium metal will turn up into aluminium oxide on heating. Children, till now I told you, when we are taking the oxide like magnesium, sodium, potassium, and we are dissolving this oxide into water, we are getting basic solution because of their formation of their hydroxides. But children, there are certain metal oxides. There are certain metal oxides which used to show the acidic as well as basic properties, and such oxides of metals are called amphoteric in nature, and these metal oxides are called amphoteric metal oxides. In exam, generally question used to come, what do you mean by amphoteric nature of metal oxide? Give two examples. So two amphoteric metal oxides are, number one, aluminium oxide, and number two, zinc oxide. Now Next, just now I tell you amphoteric nature. Amphoteric nature means the oxide which is showing you acidic as well as basic properties. Oxides are called amphoteric oxide and nature is called amphoteric nature. Two examples, aluminium oxide and zinc oxide. Amphoteric nature of aluminium oxide. Amphoteric nature, that means oxide will show acidic as well as the basic characteristic. That means if I am taking aluminium oxide here and this aluminium oxide is added with HCl, it will give me the reaction. And when I am taking this aluminium oxide here and I am adding little base into it, it will also show me the reaction. So children, when aluminium oxide is reacting with acid, then aluminium oxide is basic in nature. And when aluminium oxide is reacting with base, then it is acidic in nature. So aluminium oxide is reacting with acid as well as base. That is why we are calling it as amphoteric oxide. When aluminium oxide is reacting with acid, it will give me aluminium chloride because I am adding hydrochloric acid here along with byproduct water. And when aluminium oxide is reacting with base, it will give me another salt which is called sodium aluminate or sodium meta-aluminate along with byproduct water. So this is the amphoteric nature of aluminium oxide. Now amphoteric nature of zinc oxide. Zinc oxide will also react with acid or HCl. Zinc oxide will also react with NaOH. When zinc oxide is reacting with acid or HCl, it is showing its basic characteristic. When zinc oxide is reacting with sodium hydroxide or base, it is showing its acidic characteristic. When zinc oxide is treated with hydrochloric acid, zinc chloride will form along with water. When zinc oxide is reacting with sodium hydroxide aqueous solution, it will give me sodium zincate along with water. Children, when question is asked, prove that zinc oxide is amphoteric in nature, you need to give these two reactions. After two reactions, you need to state here in these two reactions, it is proved that zinc oxide is reacting with acid and zinc oxide is reacting with base also. That is why it is amphoteric. Similarly, the question used to ask, how can you prove this aluminium oxide is amphoteric? Or describe the amphoteric nature of aluminium oxide. So children, in every case, you need to provide these two reactions where you are going to show the reaction of oxide or amphoteric.